Welcome, my friends. In this video, we will discuss two more properties of logs, which are the log of a product and the log of a quotient. The log of a product property says that if you have log base a of x times y, that can be rewritten as two separate logs, log base a of x plus log base a of y. This property can be used in both directions. If you have two separate logs in your problem that are added and they have the same base, you can write them together as one single log where the arguments are multiplied. Alternatively, if you have the log of two numbers multiplied together, that can be rewritten as two separate logs. The log of a quotient says that if you have log base a of x over y, that can be written as the difference of two logs, log base a of x minus log base a of y. Again, this property can and often is used in both directions. If you have two separate logs in your problem that are subtracted and the bases are the same, you can write them together with an argument which is the quotient of the two logs. Alternatively, if you have the argument in a log that can be expressed as a quotient, it can be rewritten as two separate logs that are subtracted. Let's take a look at some examples. Say you have the natural log of 3 plus the natural log of x minus 3 is equal to 3, which we would like to solve for x. Well, notice we have two logs added together with the same base. They are both natural logs, so they both have the same base e. That means we can rewrite the problem as a single log that has an argument that is the product of the two logs, using the log of a product property. Essentially, we have the right-hand side of the formula in our problem, and we want to rewrite it as the left-hand side in one log that has an argument that is the product of the arguments in our problem. So we have the natural log of 3 times x minus 3 is equal to 3. We can distribute the 3 into the parentheses to get the natural log of 3x minus 9 is equal to 3. We know we can rewrite a log in exponential form as blank to the blank equals blank. I always remember left, right, and center to know what the blanks are. Left is the base of the log, which is e. Right is the answer, which is 3, which is the power on e. And center is the argument, which is 3x minus 9. Next, we add 9 to both sides to get e to the third plus 9 is equal to 3x. Divide both sides by 3 to get e to the third power plus 9 divided by 3. This is an acceptable final answer, unless you are asked to find a decimal approximation. If that's the case, then you will need to use a calculator. If I want to type this all in one go, I need parentheses for the numerator. We have open parentheses, e to the third power plus 9, close parentheses, divided by 3, which is equal to about 9.7 if we round to 2 decimal places. Let's try another one. We have log of x plus 1 minus log of 2 is equal to 2. This time we have two logs with the same base of 10, which are subtracted. Remember that if you don't see a base written on the log, we assume it is base 10. Since we have two logs that are subtracted, that means we can write them as one log that has an argument which is the quotient of the two arguments of the logs. We have log of x plus 1 divided by 2 is equal to 2. Our problem had the difference of two logs, which is on the right-hand side of the formula, and I've just rewritten the problem with a single log that is the quotient of the two arguments. Now we can rewrite this in exponential form, as blank to the blank is equal to blank, using left, right, and center. Left is the base on the log, which is 10. Right is the exponent, which is 2. And center is the argument of the log, which is x plus 1 divided by 2. So we have 10 squared is equal to x plus 1 over 2. 10 squared is just 100, so we can rewrite this as 100 is equal to x plus 1 over 2. Next, multiply both sides by 2 to get 200 is equal to x plus 1. Subtract 1 from each side to get x is equal to 199, which is our final answer. Alright, my friends, that wraps up this video discussing the product and quotient properties of logs.